Hello again, my name is Michael Fudge, and this is another lesson in learning to program in Java. We're up to Lesson 10. Lesson 10 and Lesson 11 cover iterative structures like loops. Today we'll be doing for loops, and in Lesson 11 we'll be doing the while loop. Today's agenda: first we'll talk about incrementing and decrementing variables. Then we'll introduce the iterative structure known as the for loop, and we'll have a couple of demos of the for loop statement. Before we look at iterative structures, we need to look at one of the key elements of making a loop go, and then of course making the loop stop so that it doesn't run forever, and that is incrementing and decrementing variables. This is something that, while we kind of have already talked about it, it's just we haven't officially or formally talked about it in any detail, so I'd like to do that at this time with a quick demo. All right, here I am in my NetBeans IDE, and I have a new project opened up that I made called Increment Demo, and I'm just going to show you a couple of things, and I'll trace through it with the debugger so you can see how it works. I'm going to create a variable. We all know what that does, but you might be curious, what does this do? Or what does this do? Or what does this do? And the answer, of course, as you probably suspect, is that lines 7, 8, and 9 all do the same thing. And I'm going to read out to you exactly what the code means so that you understand what's happening. And then the other two are really just shorthand for the same thing. This one here says, whatever the value of x is, add 1 to it, and then assign that to the value of x. That is, overwrite x with the new value. We call this an increment because you're advancing the value of the variable by 1. The code on line 8 does the same thing. It's just shorthand notation. When you see plus equals or minus equals or times equals or divided equals, what you're saying is x equals x and then the operator. Okay, so x equals x times 1 would be x times equals 1. The last operator is the most common, and x plus plus is shorthand for saying take x and add 1 to it, and then store it back into x. So this is the most common form of incrementing that we do. There's also decrement operators. For example, we can say x gets x minus 1, x minus equals 1, and x minus minus. Those are the 3 decrement operators. So what I'm going to do is I'm going to run this code a line at a time. We're going to inspect the variable x and see what happens along the way. Let's do that now. I'm going to press F7. And you can see right now x has the value 1. This is going to add 1 to x because x plus 1 is 2. So now it's a 2. This is going to do the same thing, making x a 3. This is going to do the same thing, making x a 4. And then these are going to decrement. So this is going to take 4 minus 1 is 3, right? 3. 3 minus 1 is 2. And then 2 minus 1 is 1. Yeah, it's a very silly example, of course, but it gives you some background on a very important concept we're going to use in our loop structures. All right, let's go back to the slides. Next, let's take a look at how the iterative programming structure works. There's really 2 key components to every iterative programming structure. The first thing is called the Boolean expression. The Boolean expression evaluates and tells us when the loop should stop. So as soon as this expression is false, the loop ends. The stuff that occurs inside the loop body, these are statements that execute when they're true. And this is typically a block of statements. It doesn't have to be one statement. It can be more than one. And the way the loop works is as follows. So you come into the Boolean expression. It's evaluated. If that Boolean expression is true, you execute the statements when true. Then when you're done executing all those statements in the block, you go back up and retest that Boolean expression again. And then in the event that the expression is false, you exit the loop. And there's no more iteration. So here's the syntax of one of the more popular types of loops in Java, the for loop. The for loop is a compact style loop because all the elements that you need to control when the loop starts and exits and the incremental are all built into the top of the loop. If you look at the top, it says for, and then it says int I equals 1. That's going to initialize our variable. And then in the middle, we put our exit condition. This is a condition that when it's no longer true, the loop stops. And then in the last spot, we put the incremental, which is what we call our loop control variable. This is a variable that advances up in value until it reaches the exit condition. So in this particular example, every time it loops, it's going to print out I, and then we're going to see an output like this, 1, 2, 3, 4, 5. So you can see one of the main values of loops is that they're very compact in nature, but they can produce a lot of output or do a lot of things for us in that small compact area. All right, it's time to do some demos. We're going to take you through a basic for loop, and then I'll show you some other examples that you can do in for. Let's start out with a very basic example that will really kind of expose you to the power of iterative structures. That is, I'm going to show you how to write a program that does one thing, and then by changing one line of code, it does so much more than what it initially did. So I'm going to start out with a variable, and I'm going to set max to 10. And then I'm going to do some counting up. So I want to print that system out print counting up. Now I'm going to count from 1 to 10. Now I could do it this way. I could say system out print 1, right? And then 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's a real lame way of doing it. And the reason that we have iterative structures is so you do not have to repeat yourself. You make the computer repeat itself. So I'm going to use the for construct. Remember, for has 3 areas. The first area is where you initialize your loop control variable. So I'm going to say int, and I'm just going to call it I. Set it to 1. And then you set your exit condition using the loop control variable. When I is less than or equal to max, I want to keep looping. As soon as I is greater than max, I want to stop. And then the final thing you do is you need to increment or decrement your loop control variable, like that. And now I have a block that starts on line 10 and ends on line 12, and anything between that block will repeat as long as this middle condition is true. And what I want to say in here is system out printf I. And then when the loop's done, let's move down a line just to clean things up. Looks good. Okay, let's run our code. And there you see counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because I have an iterative structure, it's very easy to make this thing count to 100 or 1,000 just by changing this condition here. Right? This condition says, as long as I is less than or equal to max, do this. So I can easily change this to 100. And then when I run it again, now it just counts up to 100. See that? Pretty cool. And that's the power of loops, is that as long as this exit condition has not been met, it will repeat whatever's in the blocks here. Now there are about 300 different ways I could have written this for loop. And that's because Java gives you flexibility to do things a lot of different ways. For now, let's just write it this way. But let me just show you. I could have written it like this. I could have taken this out altogether and said, I don't want to do any incrementing up there. And then I could have put the incrementer here. And then maybe I don't want to do the initialization here. I want to do the initialization up here. And the loop is still going to work exactly the way we state because we have the exit condition and we're still advancing the incrementer. We're just doing it in different places. But if I run this, it should work exactly the same as the exercise I just showed you. See that? Okay, the last thing I want to show you is how this looks when we trace through it. So let me put it back the way it was. And let's change max to 10. And what I want to do is I'll set a breakpoint right here. and then I'm going to debug my program, and it's going to stop right on line 10. There I am, right on line 10. Now max is 10, and I is not defined yet. When I hit F8, I is defined as 1, and let me put a watch on I less than max. I less than max is true, so it's going to do line 11, and then when it reaches this part of the code, it's going to go back up here and retest my exit condition. I is 1, 1 is less than max. So see how it's looping, that's why they call it a loop. It's looping through lines 10, 11, and 12, and it continues, and my I is increasing until I is no longer less than 10 or equal to 10, which it exits. And now it moves me down to 13, line 13. All right, here we are in our next example. In this example, we will use a for loop again, but we'll use a decrementer to solve a very classic problem in computer science, that is singing the song 99 Bottles of Beer on the Wall. So if you're not familiar with this song, it's a song that goes 99 bottles of beer on the wall, 99 bottles of beer. If one of the bottles should happen to fall, 98 bottles of beer on the wall, 98 bottles of beer on the wall, 98 bottles of beer. And you repeat this until there's no bottles of beer on the wall. It's a rather silly and ridiculous song, but it seems to be fun while you're drinking beer, apparently. So I want to write a Java program that does this, and I certainly don't want to sit here and manually print out this every single time. While I could do that, it's not very flexible, because then what if I wanted to sing 105 bottles of beer on the wall? I have to rewrite my code. So I'm going to write this using a loop, and let's figure out how we want to do this. Let's think it through before we do it. So remember, every loop needs three things. It needs a loop control variable with an initial condition. It needs an exit condition containing that loop control variable, and then it needs an incrementer or a decrementer. Let's figure it out with our for loop. In our for loop, we need our initializer, int beers, and let's say we start at 99 bottles of beer, right? How long should we sing this song? Until we should sing the song while beers is bigger than 0, right? As soon as beers hit 0, we want to stop singing the song. And how are we going to get from 99 beers to 0 beers? We're going to take beers and subtract 1 each time. Now the rest is just printing out the message. So how's this sound? %d bottles of beer on the wall. Beers. %d bottles of beer. If one of those bottles should happen to fall, %d bottles of beer on the wall. And then we finally put our new line in there, of course. Okay, I think I did it right. Actually, I know I didn't, but I just want to show you why I didn't do it right. Let's run the song. So it says 99 bottles of beer on the wall, 99 bottles of beer. If one of the bottles should happen to fall, 99 bottles of beer on the wall. Oops. It should say if one of those bottles should happen to fall, 98 bottles of beer on the wall. So what I want to do here is, if one of those bottles should happen to fall, 98 bottles of beer on the wall. I do not want to decrement beers right here. What I want to do instead is just take 1 away from beers, but I don't want to decrement it. So that way it's showing 98, and then it goes up here and decrements it here, and then it says 98 bottles of beer. All right, let's see if this works better. 99 bottles of beer on the wall, 99 bottles of beer. If one of the bottles should happen to fall, 98 bottles of beer on the wall. And if we go all the way down to the bottom, after the song's been sung ad nauseum, 1 bottle of beer on the wall, 1 bottle of beer. If one of the bottles should happen to fall, 0 bottles of beer on the wall. Yay, we did it. Okay, so that just gives you another example of using a for loop to iterate over a block of code. And remember, when we do this, we always need to initialize our loop control variable, have an exit condition containing our loop control variable, And then last but not least, increment or decrement our loop control variable. We do all those things, we're in good shape. Okay, in this next example, which I've already written for you, and I will gladly spend time tracing through it so that you can see how it works, this program will print out multiples of a number that you enter. Remember, a multiple is that number times a specific value a number of times. So if I run through this, so enter the number you want multiples of, let's say 5. Now it's going to pretty much count by 5s up to max multiples, which is 10. See that up here? So let's check it out. Yeah. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. See how it did that? Once again, displaying the power of the loop. So the code that I have here is relatively straightforward. I mean, everything up to lines 14 are things that you've already done and you know how those work, so I don't really need to explain that. But let's try to digest what's happening in lines 15 and then 16 and 17. So line 15, we have a loop control variable named I. The initial value is 1, and the exit condition is when I is greater than max multiples. That is, as long as I is less than or equal to max multiples, we are going to repeat. And then we always need to advance our loop control variable to our exit condition, and that's done right here by incrementing. What are we going to do each time this condition in the middle is true? We're going to make a variable called answer and set it to I times multiples of. So if you type in 5 for your multiples of, it's going to be 1 times 5, first of all. Then here it's going to say 1 times 5 is whatever 1 times 5 is. Then the next time through, it's going to say 2 times 5 and whatever 2 times 5 is, which is 10, etc., etc., etc. Let me put a breakpoint on line 15 and debug it so you can kind of see it in action. The best way to learn somebody else's code by far is to run it and debug it. That way you can go through it a line at a time and take a look at what the variables are doing and inspect those variables and get a good feel for what the program's doing and how the data is changing in code. So here I am, it says enter what you want multiples. Let's do multiples of 3. And now I'm going to start here, and I is 1, and I is still less than max multiples. So I'm going to drop down in here, and then I'm going to take I, which is 1, and multiply it by 3. And then I'm going to print out 1 times 3 is 3. See that down here? And then I go back up to 4, and now I'm testing my exit condition again. But now I is 2. Right? Let me show you that. I is 2. So 2 times 3 is 6. Print that out. Now I is 3. 3 times 3 is 9. Print that out. Now I is 4. 4 times 3 is 12. Print that out, etc., 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 etc. Now, here's where it gets interesting. I'm at this step. Now I is 10. 10 is equal to max multiples. So this condition is still true. So I'm going to print out 10 times 3 is 30. Then it goes back up here one more time, but this time I gets incremented to 11, and then 11 is no longer less than max multiples. It still says 10 because I haven't executed this statement. As soon as I execute this statement, it's going to add 1 to I, test this condition. It's going to be false, and it's going to drop down here. See that? Now I'm down here, so it worked. Where people usually go wrong in their for loop is they either start the initial value too early or end the exit condition too soon. Like for example, if I said I less than max multiples, it's not going to count all the way to 10. It's only going to count to 9. See that? It only counted to 9. And the reason it does that is because this exit condition is hit when I equals 10. The exit condition is hit. So usually, if you want to include the last value, you need to say less than or equal to instead of just less than. This last example is a very small and simple example, but it's compact and does a lot of things. The first thing I want you to notice is that on line 8 we have a for loop, and on line we have a for loop. This is called a nested for. What's going to happen here is this is going to repeat as long as I is less than max, and then for the one time it does that iteration, it's going to repeat this loop for as long as j is less than or equal to max. So max is 9. So this is going to go from 0 to 9, which is 10 times. And every time it does this, it's going to print out I and j. And then when this loop is done, it's going to move down a line and do it again. The result is something kind of interesting. It's a grid of every possible combination of I and j. Let me run it. So you see I have this row here, and then I have this row here, right? And it actually prints out 100 things from 0, 0 to 9, 9, i's and j's. This row, let me explain it. So that's this for loop when I is 1, or when I is 0. Then it drops into this for loop, and it prints out 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Then this loop exit condition is false, drops down here. It moves down a line. It makes I a 1, and then it repeats the process again. Let's trace it so you can kind of see it in action. I'm going to put a breakpoint here, then give it a debug. Now I'm on line 8. I'm going to hit F8 to move on. You can see my value of I is 0. My value of j is 0. So I'm going to print out 0, 0 here, which I did. Then my value of I is still 0 because I'm still stuck in this inner loop, but the value of j is 1. So I'm going to print out 0, 1. Now the value of I is 0 and j is 2, so I'm going to print out 0, 2. And so on. 0, 3, 0, 4. See how I'm still stuck in the loop from lines 9 to 11. When do I exit out of that loop? When j finally hits the value 10, I exit that loop. Then I move down a line. That's what this line does. Then I advance I. Now I is a 1. It was a 0. Now it's a 1. And then I go into the inner loop again and start printing out values of I and j where I is 1. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Now I'm going to move down a line and do it for values of I that are 2. 2, 0, 2, 1. So you can see that there is a lot of work being done by this program, but there's very little code written to do that work. That is by far the most valuable aspect of using loops, is you can do a lot with very little code. And that concludes Lesson 10, which was programming in for loops. Lesson 11 will introduce the while loop and the various ways you can use the while loop. Thank you very much for watching this lesson. I appreciate any comments and feedback you may have. Please post them onto YouTube. We'll see you next time. Bye now.